Say, for example, if we all have the experience of wearing the tie, the most of the boys and some of the girls, the neckties and the ties. If you tied it too much and then try to rotate, some of the person's tries falls down fainting. Why this happens? And it is said that it is very easy to kill a tied person. Just you drag the tie and he will die because there will be carotid sinus syndrome, carotid sinus compression, and the person will die. So this is very easy structures, very important structures as well, that are placed on these regions superficially. And to have an idea about these structures and their interrelationships, we must divide the neck region into some cervical regions, particularly the anterior triangles, the anterior triangle and the posterior triangle. So what is anterior triangle and what is posterior triangle, and what are the boundaries of these anterior and posterior triangles? You see here in this picture, you can see the anterior posterior triangles. This region is called the posterior triangle and this region is called the anterior triangle. Again, this anterior triangle is divided into three and a half triangles. Three and a half triangles. What does that mean? Three and a half triangles means what? That means three triangles are complete and one is incomplete and completed when both sides are met. That makes the one complete. That's why it is called three and a half triangles, right? So let us go one by one. So anterior triangle is again divided into three and a half triangles and posterior triangle into one single. Still that can be divided, and there are some key muscles there, such as the sternocleidomastoid, and another is the trapezius. You'll see, you have seen it here. It is a trapezius muscle. These are the sternocleidomastoid muscle, and there are other two muscles, that is digastric muscle and omohyoid muscle. These are for the anterior triangle, but for posterior triangle, two important muscles are these two, the sternocleidomastoid and the, do you know, this is the, which one is this muscle?
Trapezius muscle.
Trapezius muscle, right. So how and what are the structures that are actually present in this region that needs to be identified and needs to be mentioned?
Brachial
So
plexus.
yes, please. Anyone, please?
Brachial plexus থাকে এখানে।
Brachial plexus. Anything else? So let us start with the formal arrangement that we always tell. What is the boundary of this posterior triangle? This is anteriorly, as you can see, the anterior border, a posterior border of the sternocleidomastoid is the anterior boundary of the posterior triangle. And posteriorly, the anterior border of the trapezius is the boundary of the posterior boundary. And base is formed by the middle 1/3 of the clavicle. And upper, or the apex, is formed by the union of the sternocleidomastoid with the trapezius muscle. Right? Okay, you can see it. Now, what is the roof? Investing layer of the deep cervical fascia. We have discussed the investing layer of the deep cervical fascia. You know it. It has got the investing layer, and other layers are the deep cervical fascia has got the carotid shape, a prevertebral layer, right? So these are the investing layer of the deep cervical fascia forms the roof, and this roof is pierced by many important nerves and structures, so as to say the external jugular vein. Then if we discuss about the nerves, then these are the lesser occipital nerve, great auricular nerve. Transverse cervical nerve is a content of the superficial fascia just above it, and there are some supraclavicular nerves that emerge behind and comes out. So these are the very, very important nerves that are present here in these posterior triangles, which actually pierces the roof of the posterior triangle. This may be a MCQ. We can promote it, we can arrange it or add some more nerves which are not actually the structures which pierces the roof of the investing layer of the, roof of the posterior triangle of the neck, right? So it's a very important and common MCQ. Now, and you know, I've told you there is some superficial structures as well as these regions. One is very important one is platysma muscle, right? I've shown you the platysma muscle in the last class. That is a big superficial muscle within the superficial fascia, and that is actually forming a base for the surgeons for the giving incisions, particularly if the incision is not given particularly and meticulously formed. Considering the arrangement of the fibers of the platysma muscle, there would be huge scars and huge bleeding due to the wrong cutting of the fibers. I've told it. So that is one platysma muscle, and these are the cutaneous nerves that are also very much superficially related. And deep to these are some muscles, some arteries, and these muscles and arteries are very important to note. Say there is a omohyoid muscle, but in the posterior triangle are called in the occipital. This region is called again occipital triangle, and you can see there is an occipital artery. If we discuss about the names of the structures present here, the contents, the occipital artery, the lesser occipital nerve, great auricular nerve, lymph nodes, and spinal accessory nerve. This is very important one. So these are the contents in the occipital triangle, and below the inferior belly of the omohyoid muscle, as someone has already mentioned, the brachial plexus, very important thing, the brachial plexus. And as the name comes, the brachial plexus, as you know it, the upper trunk, middle trunk, in lower trunk. These are present in the lower part of the posterior triangle, just beneath the inferior belly of the omohyoid. And there are two important structures as well: the subclavian artery, the subclavian vein, and the termination of the external jugular vein here also partly is there. So these are very important structures present in the posterior triangle. And one thing I've missed, you must know that in this inferior investing layer of the deep fascia, which forms the roof of the posterior triangle, is actually carried to the axilla as the axillary sheath, and the contents of the axillary sheaths are actually the continuation of the axillary sheath is the continuation of these roof. That's why any pus or any material that is found here or collected here will eventually may trickle down to the axilla, even to the arm, like the cold abscess. You know, their vertebral spines, the cervical vertebral spines may be i- affected by tuberculosis, and that is called cold abscess of the spines. And that cold abscess of the spine may burst into the posterior triangle. Then, as I've told you, this investing layer is continuous to the axilla as the axillary sheath. So the pus may go to the axilla and eventually to the arm. So this is one clinically important thing, right? Another important thing is that a few days earlier, say for example 1 year earlier, one of my very competent friend, he's a surgeon, very good surgeon. I know him personally from my medical college career, he's a very sound surgeon, but he was put behind the bar for the death of his patient. What happened, you know? You can see these are the trunks of the
Yes, sir.
brachial plexus. And if you want to do any surgery of the upper limb, you there are two ways. Either you block these brachial plexus here in the trunks, or you give the general anesthesia. If the general anesthesia is given, the person is totally down. But if the brachial block is the brachial block or plexus block is given, then he is conscious, but the hand or the arms, I mean the upper limb has got no sensation. So the surgery can be done. My friend has chosen to do the brachial plexus block, and one anesthetist was called for, and they gave the brachial plexus block, and instead of blocking these nerves, they have put the anesthetic agents into the subclavian artery. You can see the relationship so close. So instead of giving the anesthetic agents here, they have mistakenly given it here, and then and there the patient died. You can understand. The anesthetic agent, if it enters into the vein, artery, and then what will happen? Then and there, they had not even a second to recover the patient. And the anesthetist and the surgeon was put behind the bar, and eventually they came out in bail. But you must understand why this is so important to learn these anatomy. You are going to be surgeons, you are going to be the clinicians. So please keep in mind that brachial plexus is a very important procedure and should be done by very, very competent anesthetist, not by anyone who just knows the location, right? Because there is subclavian artery there, subclavian vein very close to it. So this is the lesson from the life. Okay.
স্যার
Yes, please.
স্যার এখানে যে ট্রাঙ্কগুলো দেখানো হয়েছে ব্রাকিয়াল প্লেক্সাস এগুলো কি প্রত্যেকটাতে আলাদা আলাদা করে দিতে হয় যখন হচ্ছে কি অ্যানেস্থেসিয়া দিবে তো?
না, না, না। এই জায়গাটাতে দিলে, এক জায়গাতে দিলেই সবটা ব্লক হয়ে যায়। এখানে তুমি যদি ছড়িয়ে দিতে পারো তাহলে সবগুলাই ব্লক হয়ে যাবে। তুমি তো এটার মধ্যে দিবে না, কখনো তো ট্রাঙ্কে দিতে হয় না। If you just touch the trunk, the patient will have the features and all the paresthesia and anesthesia, I mean the paralysis of the muscles responsible for these trunks. You just give the drug here outside the trunks.
জাস্ট এরিয়াটাতে দিবে।
Just around these trunks, you just spray the injection, and the anesthetic agent will block the trunk. But you'll never touch the trunk. If you touch the trunk, you'll have at least some features, the paralysis or something, or paresthesia. That means there's loss of sensation or loss of muscle power. So you can never touch the trunk. You can never touch the subclavian artery or the vein here, right?
থ্যাংক ইউ স্যার।
Welcome.
স্যার স্যার পরে স্বাভাবিক অবস্থা কিভাবে আসবে?
চলে আসবে, the effect of the drug will be lost after some time. Say for example 1 hour, 2 hour, then it will be normal. Because you'll study there is a half-life for every drug. Half-life means after some time the effect of the drug is half, then again half. So after a few hours this effect will be lost and the person will be normal, right?
স্যার যেটা মিস্টেকেনলি দেওয়া হয়েছে বলছে ওইটা কি সাবক্লাভিয়ান আর্টারির ভিতরে দেওয়া হয়েছিল অ্যানেস্থেসিয়া?
It was mistakenly given directly into the subclavian artery and the patient immediately died. এটা বুঝতে পারছো, এগুলো আমাদের জানতে হবে কেন? Very simple thing but very question of life and death is here, right? আচ্ছা, তারপরে আসুন। এখন আমরা this is elaborated here, I'm not going to detail it. The same thing, if it is written draw and label the contents of the posterior triangle, then you have to draw this one, but not this much detailed. At least you must know so that MCQs, you can face the MCQs and the questions in the Viva also, right? Okay. Here, this is a point of cervical nerve block. It is the area of the cervical nerve block. Actually, we target for this area to block the brachial plexus and everything, right? This is the details of, I'm not going to detail it. And now come to the anterior triangle. Anterior triangle actually contains of, we have discussed these things. What are the structures present in the midline, in the anterior part of the neck, starting from the suprasternal nose, then the tracheal rings, then the cricoid cartilage, then the thyroid bone, that is thyroid cartilage, then the hyoid bone. And I've told you, for any anatomical and practical purpose, the hyoid bone is the upper limit of the lower limit of the head and upper limit of the neck. I've told you in front. I've told you. So this is the hyoid bone, very important structure because some muscles are above it. These are called suprahyoid muscles, and some muscles are below it, and these are called infrahyoid muscles. That is also another question, MCQ, very commonly given or asked for. Okay, so this is the triangles, the anterior triangles altogether. This is the half of the submental triangle. This is the digastric triangle. This one is the muscular triangle, and this is the carotid triangle. Let us discuss one by one. And before that, just have a look. Let's just have a look on these two muscles. This is the one, digastric. Di means two. A gastrum means belly. As this muscle has got two belly, gastric means belly. So, and it has got two belly. You know, there all the muscles have got a belly and a tendon. Some of the muscles, most of the muscels have got a belly and a tendon insertion for insertion. So this is one belly that is called posterior belly of the digastric muscle, and this one is called the anterior belly of the digastric muscle. And you have studied it from the digastric fossa of the mandible, the anterior belly arises and goes to the hyoid bone. Again, the posterior belly arises from the mastoid process and goes to the hyoid bone, and they are attached to the hyoid bone by a tendinous intersection and the tendinous strip to the hyoid bone. And this one is the omohyoid muscle, the superior belly and inferior belly of the omohyoid muscle. These two muscles actually divides the anterior triangle into four regions or four triangles. One by one, let us discuss about that. This is the submental triangle, right? Submental. So mentum, submental. So this location will be where? On its side it will be the, you can see it, the anterior belly of the triangle, digastric muscle. Base would be the hyoid bone, and the apex would be the chin or the symphysis menti, right? So this is the submental triangle, and its floor is actually formed by the mylohyoid muscles. Mylohyoid muscles, two which meets to the midline, the median raphe. This is the median raphe where the two sides meets, and there are some actually not that much important structures here. Some submental lymph nodes and the beginning of the anterior jugular vein. These are the contents, and some these lymph nodes swell due to the infection or infection of the tongue and this region. So this is not enlargement of the infection of the mouth, floor of the mouth, tip of the tongue, and it may cause the swelling of these lymph nodes. So we just have an idea. This is the submental triangle. But after that, you can see there is another triangle which we have called the digastric triangle or submandibular triangle. So you can see it. This is the digastric triangle or submandibular triangle, where it is bounded inferiorly by the anterior belly of the digastric muscle, posterior inferiorly by the posterior belly of the digastric muscle, and meeting point is, as I've told you, there is a tendinous strap which holds it to the hyoid bone, and base is formed by the base of the mandible. This is the base of the mandible. Actually, there is you can, whether you can, I don't know whether you can see, there is a dotted line which goes to the mastoid process. This is a base of the mandible is extended to the mastoid process by an imaginary line, and that forms the base of the digastric triangle. And apex is formed, as I've told you, the intersection of the tendinous tendinous which is attached to the hyoid bone. So this is the digastric triangle, right? Can you see it? The digastric triangle here?
Yes, sir.
Yes, yes, please. And let us put all the structures that are present here. This is a very important one because so many important structures are here, and we must know the locations and their relations one by one. Say, for example, in the anterior part of the digestive triangle, we can see a big gland, salivary gland, that is the submandibular gland, and along with the are the mandibular lymph nodes. Right. What else you can see here? You can see a big nerve here, hypoglossal nerve. Hypoglossal nerve is this one, the hypoglossal nerve. And you can also see some structures there. These two are very important. Facial artery, you know, it's the tertius artery and the facial vein, right? So these are the structures that are present in the anterior part, and along with the facial artery and vein, the myeloid vessels and nerves. We can see it. Is there any other picture? No. This is the carotid triangle. So this one we can see. So the submandibular lymph node, the hypoglossal nerve, lymph node and submandibular gland, hypoglossal nerve, facial artery, facial nerve, myeloid vessels and nerves are there. Myeloid vessels and nerve are there here, and submental artery is here. So these are the structures that are present in the anterior part of the digestive triangle. And in the posterior triangle, there are so many important structures as well. There is the external carotid artery. You can see this one is the external carotid artery and its branches and the carotid sheath, which contains, you know already, the internal carotid artery, the common carotid artery, the internal jugular vein, and the vagus nerve. So these are also present here. And structures passing between the external carotid artery and internal carotid artery. What are the structures that are present that passes through the or between the external? This one is the internal and this is the external. What are the structures that passes through? Can anyone tell me? Okay, this I'm telling you. This is the styloid process, the stylothyroid muscles, and the branches of the branches of the external carotid artery, and you can see the nerves. The nerves are here also. So these things are present passing through the external and internal carotid artery in the posterior part of the digastric triangle. So you can understand this triangle has got so many important structures in it or in this region, and we must be careful to do whatever we do in this region for managing a safe procedure. Whatever we do, this is a motto as a physician, as a clinician, there is a doctor. Our motto is that if we can't do any good to any patient, we must not do any harm to him or her. Right? This is our motto. So if we don't know these so many structures are present here, we'd be definitely damaging all these structures. That's why the knowledge of anatomy is very important. Now let us come to another triangle that is also very important in all the respect. This is very important one is the carotid triangle. Carotid triangle, as the name implies, that must contain the carotid structures, the carotid vessels. In all the three carotid vessels, carotid arteries, that is the common carotid artery, external carotid artery, internal carotid artery, all are present here. So this is called carotid triangle. Also, there are other structures, but major name came from this one. So what is the boundary of this? Superiorly, you can see the superior, the posterior belly of the digastric muscle, and this is the anterior belly part of it shown, and this is the hyoid muscle. So this is the posterior belly of the digastric muscle. Posteriorly is the anti-inferior, if you say. So this is the omohyoid muscle, as I've told you. So this is the anterior belly of the omohyoid muscle, superior belly of the omohyoid muscle. Sorry, this is the superior belly of the omohyoid muscle, and this is the, and this was right, the posterior belly of the digastric muscle. And this one is the and this is posteriorly the anterior border of the sternocleidomastoid muscle. This is the sternocleidomastoid muscle, and the attaching or base or apex are you can see from here. This is the triangle. Interestingly, you can see many structures that are very important to know, and some of you had wanted to know it in the last class. I'm coming to that point. We have 20 minutes to 25 minutes, so we can conclude that by the time. You can see a bit little detailed of these structures you must know. What are the contents of the carotid triangle? First of all, the carotid arteries, as I've told you, the common carotid artery, the external carotid, the internal carotid artery, and its first 5 branches. You know there are 8. How many branches are there in the external carotid artery? Have you studied it yet? These things?
No, sir.
No, sir. Okay, I tell you there are 8 branches. Out of these, first 5 branches are present here. So you can understand, first 5 branches are present here. Which are the five branches? Superior thyroid artery, then the lingual artery, the facial artery, the occipital artery, and what is not here, the posterior auricular artery is here, the branch, and other branches. These are the 5 branches present, and this ascending branch of the pharyngeal artery is, though it's a branch of the, branch of the carotid triangle, external carotid artery. This is the 6th, and the terminal last 2. Superficial temporal and maxillary artery. These are the all 8 branches. Out of them, 5 branches are present. First 5 branches, and the external carotid artery itself, and the common carotid artery and internal carotid, all are present here. Right. Next, carotid sinus and carotid body. What are these two things? You can see there is a dilatation at the bifurcation of the common carotid artery. This is a dilatation. You can see dilated area. This area is much more dilated than this one. So this dilatation is called carotid body sinus. And you, though you don't see here, this is region, this is a structure just behind the bifurcation outside. This is not inside. You can see it in your in a book, but here the color has become less contrast, so you can't see or just have an idea. This is the location of the carotid body. This is yet another structure. I'm just going to detail it a bit later, just have an idea where it is located, but it's not an inside structure. It is an outside structure of the carotid system, arterial system. It's called carotid body. What are the function of this carotid body and sinus? I'll be telling you.
Baroreceptor.
All right. These are the baroreceptors and these are the chemoreceptors. I'll be telling you what does it mean and what is the implication of it. Right. So these things are very important for our life. We consider that autonomic nervous system. I've told you. I'm coming to this after the completion of these triangles. I'll be discussing about the visceral reflexes. Some of you had wanted to know about the visceral reflexes, and that is very much pertinent to this carotid sinus and carotid body. That's why if we get the time after the discussion of the triangles, we'll be discussing about these, the visceral reflexes. Okay. So before going to that, we must finish. We must finish up the structures. Rest of the, yes, please. Oh, rest of the structures. Okay. Rest of the structures are what? So we have said that this is the carotid, common carotid artery, external carotid artery, internal carotid artery, and there are 5 branches. Next, carotid sinus and carotid body. Next, the last 3 are cranial nerves. So you can see the cranial nerves. What are the cranial nerves? Have you studied? There are 12 pairs of cranial nerves. Out of them, last 3 is the 10, 11, 12. So vagus is the 10th one, 11th is the spinal nerve, and this one is the 12th is the hypoglossal nerve. So vagus 10th, spinal Accessory is the 11th. Spinal accessory is a part of it. The accessory nerve has got two roots, the spinal root and the cranial root. Here you can see the spinal root of the accessory nerve and vagus nerve, and the 12th one, the hypoglossal nerve, are all three important nerves, are cranial nerves, are present in this triangle. Next, what? Ansa cervicalis. Can you see it from here? This is a U-shaped loop of nerve. This one is the U-shaped loop of nerve. That is called ansa cervicalis. Ansa cervicalis. How it is formed, I'm going to tell you. Just now you identify the structures here. Along with that, you can see the internal jugular vein here, and some deep cervical lymph nodes. These are the lymph nodes. And one more important thing is the cervical part of the sympathetic trunk. So you must be able to recall all these things in groups. And why always I tell you that study in groups and don't amalgam, mix up one with another, then you'll be missing. Say for example here, if you start with the arterial structures, then is the common carotid artery, external carotid artery, internal carotid artery, and the five branches, first five branches of the external carotid artery. So arterial side is over. Now, if you want to say the vessels, then the internal carotid artery, and then the lymph nodes on it, then you have an imagination that there is a swelling of the, in your mind, just have an recapitulation that there is a swelling in the termination or bifurcation at the bifurcation site of the common carotid into internal and external carotid. That is called the carotid body, a sinus, and there is a body-like structure that's outside, which is richly supplied by the nerves. That is called carotid body. And there are some nerves. So what are the nerves? Very important, three nerves. The last three cranial nerves, the vagus, the spinal root of the accessory, and the hypoglossal nerves. And one more is the ansa cervicalis. So by this, you can have an idea, or you can remember all the structures present in the carotid triangle in very simple way. That is why I always tell you to go through the figures. Books are there written in black and white, but figures are multicolored and shows much more information. And for better retainment, you always go through the figures and match them with the figures, what content you have got in your book in the written form, right? That is a very easy way and very effective way of learning. The last one, okay. If as the name answer cervicalis has come, we have a chance to discuss about it. We can take a chance to discuss about it. What is answer cervicalis? You see, this is the hypoglossal nerve, and actually it is a nerve formed by the ventral rami of the first, second, and third cervical spinal nerve. Ventral rami of the first, second, and third spinal nerve forms the answer cervicalis, contributes to the formation of answer cervicalis. How? You see, some fibers are carrying with the descending five branches of the hypoglossal nerve. This is carrying the C1, and this goes down. And C2 and C3 makes a loop-like structure, goes around, and then meets with the descending one from the hypoglossal and completes the ansa cervicalis. This nerve actually supplies all the infrahyoid muscles. Ansa cervicalis supplies all the infrahyoid muscles except the thyrohyoid, which is supplied by the hypoglossal nerve itself. So the thyrohyoid, now you can see it, thyrohyoid is supplied by the hypoglossal nerve itself. But other than that, all the infrahyoid muscles like the sternohyoid, sternothyroid, omohyoid, these are supplied by the ansa cervicalis. This is a common question. Write short note on ansa cervicalis. So you have to write what are the contributing rami of the roots of the ansa cervicalis, how they are joined, and which one brings what, and which one supplies what muscles. So this is very great, and you have to draw this figure as well. Uh, this is in short about the ansa cervicalis. And let us go back to those two structures, the carotid body and carotid sinus. This is the carotid sinus. This is the carotid sinus, right? So this is this dilatation, fusiform dilatation, and it is highly innervated by the hypoglosopharyngeal vagus and sympathetic nerves. Glossopharyngeal vagus and sympathetic nerves, and this it acts as a baroreceptor. Baro means pressure, and blood pressure regulation of the cerebral vessels are actually maintained from here. So that means it can understand or recognize whether the pressure is high or low, and accordingly they lower the supply to the brain and or increase the supply to the brain. This is a baroreceptor. And just outside, you can see there is a V structure here. This is the carotid body, right? And this is also very reddish brown in color, and is also supplied by the glossopharyngeal, the vagus, and the sympathetic nerves, and it acts as a chemoreceptor. This acts as a chemoreceptor, and it can how it can be stimulated or elicited by the excess of carbon dioxide or by the less of oxygen reduction, the reduction of oxygen, and accordingly the reflexes are formed. So what is the reflex? Now I'm coming to the point. What is the reflex? What is reflex as such? Oh, last one. It's not that important. This is the muscular triangle. You can see it. Muscular triangle. Right. This one is the muscular triangle. As you can see, the muscular triangle is formed in the midline by the midline and the anterior midline, median line of the neck, and superiorly by the superior belly of the digestive omohyoid muscle, and posteriorly by the anterior part of the sternocleidomastoid. This is the muscular triangle. So the muscular triangle is actually posterior. So the muscular triangle is actually containing some important structures, not that much, infrahyoid muscles, and mainly it is the content in this region. That's why the name is. You can see the names are coming actually by the contents, major contents or important contents, as they contain mainly the muscles, the infrahyoid muscle. This is called the muscular triangle. As the carotid vessels contain very important carotid vessels, that's why that was called the carotid triangle. So it's all about the muscular triangle. Now, if you allow me, I want to discuss about some very interesting things. That is the কি বলতে নিচ্ছিলাম আমি এই যে এগুলা এগুলো আমি একটু ক্লোজ করে নিই
Reflexes.
হ্যাঁ 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 visceral reflexes. So what is visceral reflex? What is reflex as such? Can you give me an example of reflex?
Involuntary motor response.
Right.
Reflex is an involuntary motor response due to an adequate sensory stimulus.
Right. Involuntary motor response due to any stimulus. Any stimulus, there will be involuntary motor response that is called reflex. And if we ask you about the reflex, we also are accustomed to give the answers that there is a pinprick, we withdraw the hand, or if we go too close to the fire, we withdraw the hand. That is all somatic reflex. What about the visceral reflexes? Are there any reflexes in the viscera, that is autonomic reflexes?
Yes, sir. Micturition
Of
reflex,
course
Yes,
there
sir.
are.
vomiting reflex.
Pseudojejunal
Reflex,
reflex.
defecation reflex.
Very good, very good. So there's so many. Why you're going to the abdomen? Here there is carotid body reflex, aortic body reflexes. These are all present in the head and neck. So you just come to this idea that what is reflex, and now let us get into it. So what is reflex? You have told it. So visceral reflexes are autonomic reflexes that are generated in the viscera. You can see this is an visceral reflex stimulus, and you know the stimulus for autonomic nervous system and the somatic nervous system is not the same, right? In somatic nervous system, the
Yes, sir.
sensation is pain, temperature, then vibration. These are the main things, main common somatic stimuli. But in case of autonomic nervous system, that is in case of viscera, the stimuli are either lack of oxygen or lack of blood supply, or that is the eventually results to lack of oxygen, that is hypoxia, or over twisting, that is called overstretching of the muscles of the viscera, and hypersecretion like the GI gastric pain. You know, if there you have you at least some of you have experienced that one day you have woke up in the morning and you're feeling very much agonizing, very dull aching pain in the abdomen, and you can do anything with to relieve it unless you take a medicine that is called antispasmodic drug like visceral timonium or visceral gin like medicines you take. These pain doesn't go. It's not like the sharp pain of somatic origin. It's a very dull aching, very agonizing pain, right? So that is the visceral pain, and that originated from either from the over contraction of the viscerals in the abdomen like the stomach or something like that, or there is huge secretion, excessive secretion, that is causing the irritation of the mucous membrane and that is causing the pain. Or in the heart, cardiac pain is like that. There is less oxygen, hypoxia. That's why the pain has originated from the dead or dying cells. Right. So these are the three reasons uh, pain in the there is this visceral pain can arise. That is sensory stimulus from the viscera can arise either hypoxia or overstretching or oversecretion. Whatever the cause is, there is a stimulus and the sensory receptor in the viscera will be carrying it along with the posterior root of the spinal nerve, and there is no, there's a cell body is located, but this cell body is not, or this neuron is not the same neuron that carries the sensation from the skin, that is the somatic system. That neuron also has got its cell body here, but this neuron and that neuron is not the same. Whatever, it enters into the spinal cord, and instead of ending up at the posterior root, it goes straightway to the lateral horn, where integration occurs, and the efferent no neuron comes out and reaches to the viscera. But difference is that in case of somatic nervous system, the effector neuron is only one. Single effector neuron reaches the target organ like the muscle. I've told you in the last class that the nervous system is only one, the skeletal muscle. And only single one neuron is enough to reach it, to get it to the skeletal muscle. But in case of autonomic nervous system, the efferent neurons are two. One is preganglionic, another is postganglionic. So ultimately the effect reaches to the viscera and the response is completed. This is a reflex. It doesn't need to go to the hypothalamus. As I've told you, the destination of the autonomic nervous system is the hypothalamus, whereas the destination of the somatic nervous system is the thalamus. I've told you in the one day, 2 days classes earlier, the ultimate destination of the autonomic sensation goes to the hypothalamus, and all the somatic sensations usually goes to the thalamus. Right, I've told you. So whatever, that is another point. But thing is that the sensation has come and it has been dealt with at the spinal cord level, and the reflex is completed by the efferent neuron, which has got two neurons in its arc. Now let us come to the point. Autonomic motor responses can be modified, facilitated, or inhibited here, higher center, particularly as a hypothalamus, as I have told you. But it can be completed here in the level. And there's two neurons, I've told you, that is also been said. and two types of visceral reflexes. Actually, I couldn't see what was written here due to the faces, and yeah, now I have removed it. Now I can see what is here, so it would be easier for me to continue from now on. Two types of visceral reflexes are there. One is short, one is long. How the short visceral reflexes repeatedly, it is it can bypass the central nervous system. It is the main property of the short visceral reflexes that it can bypass the central nervous system. Instead of going to the hypothalamus on higher centers, it simply, as I have shown you, it simply integrates in the ganglionic neurons or whatever it can. And finally, what is the main effect? Activities in one small part of the target organ. That means you have given the examples of what examples a bit earlier? Gastro, some reflexes you have given the examples.
Gastroduodenal.
Yeah, these are actually related to one single part or small part of the total digestive tract. So this is a short autonomic reflex, right? And it is actually works in the mostly in the enteric nervous system. And actually our central nervous system is not aware and is not controlling those reflexes. These are the properties of the short visceral reflexes or short abdominal reflexes. But there are some long abdominal autonomic reflexes, where the information has to go to the central nervous system. Right? Have I shown you the figure? Have I shown you the figure? It will be easier for you to understand. Let me just go to that figure, and that will be easy for you to understand. This figure, let us just go through this one. I've shown you. I think I have shown you. Okay, let us make it easier. So this is the stimulus has entered, and if it is a somatic sensory reflex, sensory stimulus, it goes to the thalamus, and from there it goes to the cerebral cortex. But if it is a autonomic stimulus, instead of going to the thalamus, it goes to the hypothalamus, then it gives input to the limbic system, to the thalamus and the cerebral cortex, and eventually the order comes down. But whatever the difference between the somatic reflex and autonomic reflex is that somatic reflex always has to reach the central nervous system. Somatic reflexes always has to reach the central nervous system, be the spinal cord or elsewhere. It has to reach the central nervous system. Then the lower motor neuron reaches the efferent organ. But in case of autonomic nervous system, there are two types. One is short, as I have told you. One is long. The short one doesn't need to reach the central nervous system. It can bypass the central nervous system. Actually, this I have told you it happens in the ganglion region, ganglionic neurons, and from there immediately the reflex is completed. So it doesn't need to inform the central nervous system, and mostly it is out of the control of the central nervous system. And it happens in the, where I have told you, mostly in the enteric nervous system, and to a particular part of the, not the whole. But when these stimulus enters into the central nervous system, and there the reflex is done, that is called long reflexes, that involves the central nervous system, and that is actually maintaining the relationship of the total system even with other systems. Let us go back to the slide where we had been. So this is the difference between the long reflex and short reflex. In the long reflex, you can see it has to get into the central nervous system, and processing happens within the central nervous system and coordinates the activities of the whole organs and responses in multiple organ systems. So not only within the whole organ, but also with the other organ systems, they can coordinate. Say for example, okay, I'm not going to detail it anymore. Now let's go to the particular pertinent part here in the interoceptors. What are the interoceptors? Monitor visceral target tissue organs like the nociceptors, thermoreceptors, baroreceptors, chemoreceptors. Right, these are called interoceptors or internal receptors. These are called interoceptors. Nociceptors means pain, internal pain. Pain is called nociception. Nociception, nocia means pain. So internal nociceptors means pain sensations, receptors within the body, that is the viscera, from the viscera. I've told you even the receptors for somatic nervous system and receptors for the autonomic nervous systems are not the same. They are different kinds of receptors that carries the pain of the autonomic origin. There are different kinds of receptors that carry that recognize the pain origins or stimulus for the somatic, and that other things are thermoreceptors, baroreceptors, and chemoreceptors. And these processing is subconscious, and I'm not going to solely claim this, you will not understand right at this moment. Just let's get to this point. Baroreceptors. So baroreceptors are stretch receptors monitor blood pressure changes, like where they are located. And they're located in the blood vessels, free nerves, whole organs, blood vessels, tubes of the respiratory tract, digestive tract, urinary tract. Out of them, uh, this one is very much related to us: carotid artery and the carotid sinus. Now you can see these carotid sinuses are the baroreceptors, right? So these are actually stretch receptors that monitor the pressure changes. And what do they do? I'm not going to detail it. You just have an idea. Then these are related to the autonomic reflexes. And these are done by the receptors, that is known as the baroreceptors, carotid sinus. Similarly, how do they do? I'm not going to detail it. You'll study it when you will study the central nervous system, because you'll not understand these things right at this moment. In due time, we'll be discussing about this. So let us put it for the next time. But now the chemoreceptors, the specialized neurons that detect the changes in the connections. Same thing, but here they are involved with the chemical changes, not the pressure changes, right? So what are these things? They are located in the, this one is very much related to us, carotid bodies, near the origin of the internal carotid arteries, I've told you. And aortic bodies between the branches of the arch of aorta. I'm not going to detail it anymore. What I've told you, the reduction of partial pressure of oxygen, pH reduction, and carbon dioxide, if the carbon dioxide increases, they actually are stimulated. So now you can understand what is carotid body, what is the carotid sinuses, and what are the functions of them. How do they act? This is how they act. Chemoreceptors, how do they act? This is a flow chart. You'll study it later. What I wanted to mention that please be attentive to one thing, that there are some visceral reflexes. Most of the students, even I, before coming to MPhil, I was not aware of these reflexes. Whenever a reflex was discussed, we thought about the somatic reflexes, but there is all these things are reflexing happening moment to moment, even milliseconds to milliseconds. These things are adjusting within our body. It's not that the wrong idea that fight or flight response, rest or response. That means either you will fight, that is the sympathetic nervous system, or you will flight, that is also sympathetic nervous system, or on the opposite side of that, the just opposite to that is the rest or response. That is the function of the parasympathetic nervous system. No, it's not like that. In every moment in our life, in every milliseconds in our life, these two systems are working. Then this is a very good example how the pressure and how the blood pressure in the brain and how all those things are maintained. In every moment, in every millisecond of the moment, actually, these adjustments between the sympathetic and autonomic nervous systems are done. And that is mostly done by these reflexes. Without our awareness, we are not aware of these changes are happening moment to moment, milliseconds to milliseconds in our body. That is, as it's not happening in milliseconds are happening without our sense, That's why we just completely ignore it. But if I get a pinprick and I take off the hand and I remember, yes, there's a reflex. That is one a very good example of reflex. But we completely miss this side. That's why I request you as a medical students, please try to see the whole picture, the bigger picture, right? With this request, I would like to conclude today's class. So let's, if a summary, what we have studied. We have studied the triangles. What is the importance of studying these triangles? To know the superficial structures, present very important structures there. And what else we need to know? We have to divide these triangles into anterior triangle, posterior triangle. Posterior triangle is a one only. That also can be divided into two subtypes, but the anterior triangle is divided into 3.5 triangles. And what are the structures present there? We have studied in details. What are the structures that forms the roof, the floor, the anterior border, posterior? We have studied in details. And finally, we have discussed about the visceral reflexes or autonomic nervous system reflexes, right? And what is the implication here related to these head and neck of these study of the autonomic reflexes is that carotid body, carotid sinus, these are the examples of the autonomic reflexes. And how do they do? We have not yet dealt it because this is bound beyond the scope of head and neck. It is actually the concern of the central nervous system. So when we will get the chance, we will be completing these today's session that we have started as the autonomic reflexes will be completed in the next part, next card. But we have just had the basic idea of what autonomic reflex is, what is the source or stimulus, what are the sources of stimuli of the autonomic reflex. One is high excessive. Can anyone tell me what are the sources of autonomic stimulus? Three sources I have told you. Can anyone? Anyone, please?
Hypoxia.
Hypoxia. Anything else?
Hypersecretion.
Hypoxia,
Secretion.
Hypersecretion.
Oversecretion.
over-secretion, and over-contraction or over-stretching. Right. Thank you. With this, I want to conclude today's class. If you have any question, you may ask. It would be very appreciated if you ask any question.
স্যার
Yes, please.
স্যার আমাদের বডিতে শুধু অ্যাওরটিক বডিস আর ক্যারোটিড বডিস আছে, দুইটা বডিস। মানে অ্যাওরটিক বডিস আছে আর ক্যারোটিড সাইনাসে ক্যারোটিড বডিস আছে। তাহলে লোয়ার পোরশনে মানে আর কোন জায়গায় তো মানে বডিস বা সাইনাস নাই।
ওই যে ব্লাড ভেসেলে আছে, all the blood vessels I've told you. তো ছবিটা দেখো, যে স্লাইডটা দেখো, যে কোথায় আছে। এই যে baroreceptors, এই baroreceptor লোকেশন দেখো। Free nerve endings present in the elastic, baroreceptor দেখো কোথায় আছে। Hollow organs, blood vessels, tubes of the respiratory tract, digestive tract, সব জায়গাতেই তো আছে, আছে কিন্তু এটা আমরা বুঝি না কেন, এগুলা এত ভাবে ছড়ানো আছে। ইলাস্টিক টিস্যু, যত জায়গাতে ইলাস্টিক টিস্যু আছে, হলো অর্গান যেমন স্টামাকে আছে, হ্যাঁ, ব্লাড ভেসেলে আছে, টিউবস অফ দ্য রেসপিরেটরি ট্র্যাক্ট, ডাইজেস্টিভ ট্র্যাক্ট, ইউরিনারি, এরকম সব জায়গাতেই কিন্তু আছে। আর ওগুলো তো স্পেশালি নাম করার মধ্যে তো আছে, যে নাম করা যেগুলো ব্লাড প্রেশার কন্ট্রোল, সেগুলো নাম করার মধ্যে হচ্ছে কি ক্যারোটিড সাইনাস, অ্যানায়োটিক সাইনাস, এগুলো হচ্ছে ওয়ান অফ দ্য মেজর ভেসেলসে। কিন্তু এছাড়া ওই যে বললাম, এগুলোও কিন্তু আছে, এই যে হলো অর্গানে আছে, ব্লাড ভেসেলে আছে, ছোটখাটো গুলোতেও আছে, না হলে হবে কেমন করে? All these things are actually giving response. সারা শরীরের থেকেই তো বললাম না, এটা unawarely হচ্ছে বলে we are not aware of these changes happening moment to moment, but this is happening, and these all information is actually making us adjusting with the phenomenon happening moment to moment. আমাদের শরীরে যখন তখন প্রেশার বাড়ছে, যখন তখন the pressure is lowering, but that is adjusted by these receptors, right? Stretch receptors present in the hollow organs, blood vessels, tubes of the respiratory tract. Say, for example, you are taking a food. This is stretching, and this stretch is actually adjusted by the relaxation of the muscles there. If this adjustment is not done, then what will happen? The muscles will not relax, but the food is trying to get down. It will burst, tear up, right? সেই রকম এগুলো অনেক কিছু ঘটছে আমাদের, but we are not aware of them. That is the point. বুঝতে পেরেছো? তাই এই জন্যই তো মনে হচ্ছে খালি তো শুনি ক্যারোটিড সাইনাস আর অ্যাওর্টিক সাইনাসের কথা, আর সারা শরীরে কই? সারা শরীরে এখন অভাব আছে, দেখো হল অর্গানে আছে, ব্লাড ভেসেলে আছে।
ওইগুলো তো স্যার ছোট ছোট, এই জন্য বলতেছি।
হ্যাঁ, ওই জন্য এই যে বললাম তো, এগুলোকে খেয়ালে রাখতে হবে, ছোট জিনিসকেও মনে রাখতে হবে। ভেরি গুড কোয়েশ্চেন, ঠিকই বলেছে। আর কেউ কিছু?
স্যার ক্যারোটিড বডি স্যার স্ট্রাকচারালি বা কেমন স্ট্যাটিক্স মানে নার্ভের মতো বা স্যার বা
মানে ওখানে হচ্ছে কি ক্যারোটিড বডিটা কি একটা সোয়েলিং, তাই তো? সহজভাবে চিন্তা করো, ওখানে রিচ ইন মানে নার্ভ সাপ্লাই, মানে ওটা কিন্তু ওয়ালে, ওখানে যে ওখানে ক্যারোটিড, হ্যাঁ এই যে এটা বললে তো ক্যারোটিড বডি বলছো তুমি না, তো এটা তো বাইরে, হ্যাঁ বাইরে, ওখানে একটা কালেকশন অফ দিস ফাইবারস, এই জন্য ধরো হাইপোগ্লসাল নার্ভ, তারপরে ভেগাস নার্ভ আর সিম্প্যাথেটিক নার্ভের একটা ফাইবার গুলো একত্র হয়, হয়ে একটা স্ট্রাকচারের মতো তৈরি করে।
স্যার অনেকটা গ্যাংলিয়নের মতো বা এরকম?
হ্যাঁ হ্যাঁ, টাইপ অফ সর্ট অফ দ্যাট। ওখান থেকেই এই রিফ্লেক্স গুলো সে মেনটেন করছে। ঠিকই বলেছো তুমি।
ধন্যবাদ স্যার।
আচ্ছা ঠিক আছে, এগুলো আরো ডিটেলস আমরা বলবো যখন আমরা এগুলা বলবো না, তখন মানে সেন্ট্রাল নার্ভাস সিস্টেম না বুঝলে এগুলো আসলে, যে আমি ছবিটা যদি দেখাই সলিটারি যে একটু আগে একটা কথাটা এসেছিল, সলিটারি পাথওয়ে দিয়ে, এই সলিটারি নিউক্লিয়াই, এখন এটা তো তুমি বুঝবে না, এই জন্য আমি এগুলোতে যেতে চাচ্ছি না এখন। হ্যাঁ, এরকম প্রত্যেকটাতেই এই যেগুলো দেখো, এই যে অনেক ছবি আছে যেগুলো তোমরা এখন বুঝবে না, এই শব্দগুলো এখন বুঝবে না বলে আমি এগুলোতে এখন যেতে চাচ্ছি না। যখন আমরা সুযোগ পাবো তখনই দেখো আমরা গ্রুপ গ্রুপ করে বুঝাবো, এগুলো সবগুলা চমৎকার কথা আছে, এর মধ্যে অনেক কথা আছে, ইনশাল্লাহ এগুলো আমরা সব পরে বলবো, আলোচনা করবো। হ্যাঁ, আজকের জন্য শেষ করি। তো থ্যাংক ইউ, ভালো থেকো ইনশাল্লাহ, সবাই দেখা হবে ইনশাল্লাহ।
Thank you, sir.
আসসালামু আলাইকুম।
আসসালামু আলাইকুম স্যার।
ওয়ালাইকুম আসসালাম।